Hello students of class 8 once again. I'm Sudhir and welcome back to my video. In today's video, I will show you the solutions of plotting the graphs of exercise 15.3 and this exercise to be started. I would like to uh, generalize some points of this. I mean, I would like to generalize some topic of this exercise. So here some applications of the graph is there in our day-to-day life. So let us see what good the applications are. So in everyday life, you might have observed that the more you use a facility, the more you pay for it. For example, if you used an electric bill, or if you consume the power, then the more bills are coming in. And if you want to buy more things from shop, then you need to pay more money, stuff like that. Situations are there in our daily life, isn't it? So in these situations, we can use this plotting of graph also. Let us see. If more electricity is consumed, the bill is bound to be high. Yes. If you are using television, if you're using uh, any kind of appliances more and more, like fan, AC, everything at a time, then the the consume will be becoming more and the bill will be becoming higher there at the end of the money, isn't it? That things happen in our life, isn't it? If less electricity is used, then the bill will be easily manageable. Means the bill will be less, isn't it? If we used the electricity less. This is an instance where one quantity affects the other. Amount of the electric bill depends on the quantity of the electricity used. We said that the quantity of electricity is an independent variable. Once again, we said that the quantity of electricity is an independent variable, or sometimes controlled variable. And the amount of electric bill is dependable variables. The relation between such variables can be shown through graph also. Means, see how much you consume the electric, that that depend on it, that how much the bill will be coming in it. Also then, if you want to buy more uh, quantity of sugar or more quantity of rice, then the bill used to be bigger, isn't it? The less you buy the quantity of the rice, then less price you have to give. So what happened in the situation of daily life? So it happens that one value, or one quantity is depend on the other quantities, isn't it? Yes. So like the kgs, the amount, I mean the weight of the sugar, or the weight of the rice that you have to buy, or the amount of, I mean the quantity of electricity that you used in your home, they are called independent variables, or sometimes it is known as the control variable. Okay, means it depend upon us that how much we use. But what happened, the bill or the price, that means the bill or the amount to be paid, okay, at the end of this day or at the end of the month, how much we consume the electricity, or how much we uh, bought the sugar or rice from the market, that prices depend on that how much quantity we get, or how much quantity we consume, isn't it? So like that, two variables are there. One is dependent and one is independent. So independents are also known as the control variable. Okay, clear? For example, one more example also you can just think about it, that is interest of some amount. For example, if you go and borrow 1,000 rupees, then you have to give 10% of interest, for example, at the end of the year, isn't it? If you borrow more money, then you have to pay more interest. So like this, situations are there that two quantities come out, that one is dependent and one is independent. Okay, clear? It means the amount of the interest is depend on the amount of the money you borrowed, or the amount of the principal that you uh, get it, isn't it? Yes, like this. So These applications are also can be applied to show in the graph, isn't it? This application can also be shown in the graph that how the amount used to be varied, isn't it? According to the variation of the other amount or other quantities. Okay, so we'll find some questions in the coming of exercise 15.3 relating to this points that dependent and independent values. Okay, clear. So let us see the questions, some questions from the exercise 15.3. Okay, so here we go. Now we have exercise 15.3 and question number one. So in question number one is saying that draw the graphs of sorry draw the graphs for the following tables of values with suitable scales on axis. Axis means plural form of the axis. Okay, then A. So some more questions may be there, A, B, C. So this is the question number one. A, cost of apple is given here. The number of apples, one. The cost of apple is given here, one, and number of apple is one here, and the cost is given here is five. And if two, then 10. If three, then 15. If four, then 20. If five, then 25. You can see that the amount of the price is raising as per the number of apple increases, isn't it? And if it is reduced, then the amount will come down. So this is called the dependent and independent quantity or variables. Okay, the more apple you got, the more money you have to spend, isn't it? So this also can be plotted in the graph. So you must think that the number of apple is x value and the cost is y value here. And this one column will make the coordinates of x and y. Okay, and that you have to be remember that. For example, the coordinate 1, 5, coordinate 2, 10, coordinate 3, 15, coordinate 4, 20, coordinate 5, and 25 like this. Okay, means x value will be 1, then y will be 5. If the x is 2, then y is 10, and if the x is 3, then y is 15. Like this, you must know the logic or the idea of plotting the graph as per the coordinates we are getting. So the coordinates or the value must be always tabulated in this form. Okay, the question was given in tabulation, so no any confusion, but you have to take that number of apple as x and number of actually the cost in rupees must be y value. Okay, y coordinate is okay. So let us see solution we have here. So in solution, so I just explaining here that in order to represent the given data graphically, we represent number of apples on the x-axis and cost of the apple in rupees on the y-axis. The ordered pairs. The ordered pairs means the coordinates will be 1, 5, 2, 10, 3, 15, 4, 20, and 5, 25 are plotted as points and are joined by the line segment as shown in the figure that gives required graph. Okay, so this is the graph here. So in this graph you can see that a y-axis and x-axis are there, and on the x-axis we take up to the point 5 here, unit 5 here, because the highest value of x is 5, highest value, isn't it? And in the price column you can see the highest is 25, so we take up to 25 uh, units. Okay, means some units that the unit give the value up to 25. Okay, so for that, what happen, every 1 units will equal to 5. Okay, means 1 unit will equal to 5 number of, I mean 5 rupees, 5, 10, 15, 20, 25 like this is to go. Okay, clear. So here you see it is up to you that whether you want to take one box as of 5 or uh, 2 as 5. That is dependent upon you. 2 5, then 4 will be 10, then another 2 will be 15, another 2 will be 20, another 2 box will be 25. Like this you can take it. Okay, clear. So this is called the suitable scale. That is okay, clear. Suitable scale means on the x-axis every two units is as one apple. Okay, then here every two units as a rupees 5, every two units. Okay, it means every 2 units is equal to 5 rupees. Okay, like this. So that is the scale. Okay, clear. and then you can see here first to be plotted 1 5. So 1 is the value of x, so 1 is here, and you should come, so that it meets to the point where the coordinate of y is 5 here. So this is the point. So you have to make one point here before the line have to be joined afterward only. So first of all, you find out the points. So this point is the coordinate 1 and 5, and next to 10. So from 2, then you come up to 10, where the 10 is. Then you take one another point here. Okay, make it little big or darker points. Then again, 3 15, from 3, then 15 here, isn't it? And then next is 4 and 20. So 420 coordinate will be here, and another 5 and 25 coordinate will be here. And after that, after you get this, then you join the dots, or you join the points. Okay, you join all the points that represent the coordinates of x and y here, and you will find that line is passing through the origin. Okay, clear like this. Yeah. So next we have question B of this same question number one. So here in the B, you can see uh, tables are given here. So this is a table of time distance graph. Okay, time distance graph. The graph will be called time distance graph, because here in the table it shows the time taken by the car and also distance covered by the car. So graph will be called time distance graph. Okay, so now what we have to do is that we have to draw the graph of this distance traveled by the car. So given here time in hours, like 6 a.m., 7 a.m., and 8 a.m., and 9 a.m. here, and distance as 40 kilometer, 80 kilometer, 120 kilometer, and 60 kilometer here. And you can see that as the time increases, the distance also used to be increases. Okay, yes, and let's see the next what we have. Some more questions are here. There is question Roman number one: how much distance did the car cover during the period 7:30 a.m. to 8 a.m. 7:30 is not there, but still we have to find out from the graph. That how to find out, that we'll see together. Okay, and one more question is there. There is question number two: what was the time when the car had covered the distance 100 kilometers since it started? So it means that when the car started, when it covered 100 kilometers, what was the time that we are going to find out from the graph? But from here, we cannot find out where is 100. 100 is not given here. 120 is there, even 730 is not there, isn't it? So we can find this all information from the graph that we plotted to be plotted. Okay, so let us see the next. Next, we have the solution of this question number B. Here is the graph. Okay, in this graph, you can see that some values on the y-axis and some value on the x-axis here. So this it is here. Okay, clear. So the y-axis is here and y-axis is here. Okay, clear. So this is not the x-axis. This is another uh, line. Let us see. So here we have the graph of the next question, Roman B. And in Roman B, let's see what is the question. The Roman B is saying that we have to draw the time distance graph, isn't it? So in order to draw the graph, what we are supposed to do, let's see, in order to draw the time distance graph, we represent the time on x-axis, time on x-axis, and the distance in kilometer on y-axis here. You see from start 10, 20, 30. So its unit used to represent 10 kilometer, and the highest kilometer is 160 here. So we have to take up to 160, because 160 was the highest or the largest distance covered, isn't it? So we have to take up to 160. So, and you can make every unit as 10 10 10 20 30. So every number is the multiple of 10 10 only. 10 to 10 10 1 10 2 10 3. Okay, 1 2 3 as it goes up. Okay, and on the other side, you see in x-axis, I represent the hours here, that is in hours, time in hours, 6 a.m., 7 a.m., 8 a.m., and 9 a.m. here. So instead of writing here, they are showing here, doesn't matter. It's just to be a convenient only, because the places is not there. Okay, it doesn't matter. It's not that we take the x-axis here. X-axis should be where the zero is there. Okay, yes. And then, my dear student, scales are taking like this: 2 units equal to 1 hour. You see here 2 units, 2 units 1 hour, and on x-axis, and you can see that one unit as 10 kilometer on y-axis. Okay, you take it like this. You can follow the same thing, or you can just follow your own idea according to your convenience of the graph paper you are having. Okay, so but here in my graph I used to take two units as 1 hour, two units as 1 hour. Okay, two units as 1 hour, so that's 6 to 7 1 hour, 7 to 8 1 hour, 8 to 9 1 hour, like this. Okay, clear. And then on y-axis, every 1 unit is equal to 10 kilometer. Okay, then plot the point. Now plot the point. So this is the point from the table we have. Yeah, from the table we have. Then you can see here, coordinates are here 640 and 7 and 88, 120 and 9, 160. This is a coordinate uh, from the tabulation, isn't it? So you can see here 6 is the value of x. So 6 means 6 a.m. Okay, the time. Okay, at the time 6 a.m. It cover up to 40 kilometers. So 40, you can see the 40 will be in between 50 and 60. Okay, 50 and 60. So this is here actually 40. You have to take little up. Okay, it doesn't matter. It's taking just exactly on 50. 50 is not supposed to be little less. Okay, now 40, 40 here. Okay, 40 here, it should be 40 here. Then yeah, so this, then once again you come back here, and in order to plot this second graph B of this question number one, just see that I'm going to explain here that in order to draw the time distance graph, we represent the time in hour on x-axis and the distance in kilometer on y-axis, and the scale is 2 unit is equal to 1 hour on the x-axis, and x-axis 2 unit as 1 hour. Then means every two boxes you can take it. Okay, clear. And 1 unit, 1 unit on the y-axis and as 10 kilometer there. So you must, so these are the scales of the graph to be taken. Okay, and then you see plot the points on the graph. That is six, the coordinates are 647, 80 and 820 and 160. Okay, and then you have to join the plotted points, okay, on the graph with line segment, and you'll obtain the graph. Okay, then here you see, my dear student, one question is there: how much distance did the car cover during the period of the 7:30 a.m. to 8 a.m.? So the answer is given here, that clearly from the graph we can see the distance covered by the graph during the 7:30 to 8 is 20 kilometer, and it is getting by 20 minus 100, it is 20 kilometer. Okay, and the next question, one number two, is what was the time when the car covered at the distance of 100 kilometer since it started. Okay, so you get the answer here, the time when the car had covered since it start at 7:30 a.m. When 7:30 a.m. only, that it covered 100. It is the answer. The answer is from this question number one, isn't it? Because at 7:30 it covered 100 kilometer. That from the graph only you can find. So this graph, I want that you make this graph. Okay, very simple. You just try to get it on the points on the graph, the coordinates on the graph, then you will find all this answer. Answer is already given here, but you try to get this in your graph, okay, when you practice. So like this, let us go to the next. Okay, now my dear student, next question, we have question Roman C of this one, number one, and Roman C is interest deposits for a year. So you can see interest on deposit for a year given here in this table. So it is in rupees, okay, and the interest also in rupees. So if it is 1000, then 80 rupees you have to be deposit increased, and if it's 2000, then 160. If it is 3000, then 240. Like this, you can see that the amount of the interest is increasing as per the increase of the deposited amount, or we say this is principal amount. Okay, clear? So this we can plot in the graph. So let us see how it can be plotted in the graph. Now next is the solution of the the C, and this is the graph we have here. Okay, clear, this is the graph we have. So in this graph you can see that the value on the x-axis are taking as uh, 4 units as 1000, isn't it? Next for 2000, next for 3000, like this. Okay, so let us see how we can explain here the drawing in see. The solution is, in order to draw the um, principal simple interest graph. See why the name of this graph, please remember, simple interest, sorry, simple interest graph. This is called principal interest graph. This is a principal interest graph, principal interest graph. Okay, the deposited money is called the principal, isn't it? Or capital money is also known as principal money. So principal simple interest graph we say. Okay, clear. We represent deposits on x-axis and simple interest on y-axis here. That is in rupees. Okay. Then uh, the scale 1 unit will be equal to 1000 on the x-axis, and 1 unit 80 rupees is equal to 1 unit is equal to 80 rupees on the y-axis. 80, next unit 116 is 240, like this, the multiple of 80. Okay, while in the unit you can see for you it 1 unit means it is up to you that how many square that you want to make as 1 unit. Okay, two square, or two boxes, or three boxes, but they are units. So in unit the value is given here as 80 rupees. Here the unit 1 unit is given as 1000. 1 unit, 2 unit, 3 unit, 4 and 5 to 5 unit, as the highest value is 5000, isn't it? And here the highest value is 400, so up to 4 unit, up to unit having value up to 400 we are taking here. And now what we have to plot, let us see, we are going to plot this point first 1080 means if it is 1000, then rupees 80, that is x value is 1000, then 80 will be here. So this is a point here, and next to 1000 and 160, 2000 and 160 is here. Okay, yes. And next 3000 to 40, 3000 is here, and 240 is here. So this is another point here. And next 4300, 4300 here, and then 5400 is here. Okay, clear. And then some more questions are there. Join these points on to obtain the required graph. Okay, then you see here, yes, the graph passes to the original. Yes, the graph is passing to the original. Okay, clear, yes. And some more is there. Question next, the corresponding corresponding to the rupees 250, 250, okay, sorry, 2500, the corresponding rupees, the corresponding to rupees 2500 on the x-axis. 2500 will be the middle of this 2000 and 3000 will be 250, 2500. Once again, 2000 and 3000, middle will be 2500, and from there you just come the coordinate of y. So this is the point that will have the coordinate of y, and you just come straight. Okay, straight, and just reach the y, then you get here 200. Well, how it get 200 is that the middle point of this 160 and 240 will be 200. How you'll get, you add this 160 and 240 and divide by 2, you'll get 200. Here also, if you add this 200 and 2000 and 3000, then you will get 2500. Okay, if you divide by 2, the sum, if you take the mean here, if you take the mean, or if you take the average, you get the 2500. If you take the average of these 2 points, 160 and 40, you get the 200 here, isn't it? That means the coordinate of rupees 2500 of y will be 200 here. That's all. Okay, clear. And the interest is how much? 200. That's all. If means the interest of 2500 will be 200 again. And another more again here, question next, number 3 question. Okay, corresponding to the two rupees 280. So 280 here, how you will get the 280 here? 280 will be the middle of these two. If you add these two, 320 and 240, we add together and divide by 2, you will get 280 here. And this is the middle point. Okay, middle point of this 2 point, it will be 280. If you just come straight and touch the line and come down straight line perpendicular to the um, y x-axis, then you will get here the middle of this 2 point, 3000 4,000, that is 3,500 here, right? So you'll get here the corresponding of 280 will 280, the corresponding of 280 of x means corresponding to 280 of x-axis will be 3,500. Okay, clear? So here we have. Okay, now let's go to the next. Next we have to draw the graph here of this given. Okay, yes. So next question number two we have. So in question number two, we have to draw the graph of this given tabulation here. So graph is given here, and you can see that asking you, is it a linear graph or not? Yes, it is linear graph. You can see here. Okay. Yes.